So somebody gives this seed AI this mundane goal of creating paper clips. And then because it's a seed, like a proper AI that's going to actually improve itself over time, then what it does is it starts to learn more about the world and figure out more long-range planning, try to determine what could inhibit it from creating this goal. And so it will realize, hey, these humans could be a threat to me. I might need to isolate myself or copy myself onto other systems and distribute myself so that I can't be unplugged or taken out.
Welcome to InFi, the future of finance.
Hey everybody, welcome back to the InFi podcast. Today, I am very happy to be speaking with Christian Hubbs, who is our Chief Technology Officer, CTO here at Infineo. Before, he was our Chief AI Scientist, and he's been recently promoted. And now he's in charge of all of our technical operations. Among other things, Christian has a PhD in machine learning from Carnegie Mellon, and he is an expert on artificial intelligence. And so we're going to spend a few moments in the beginning of this discussion just having him give some of his background to make sure you understand this is an important guy. And then we're going to talk about all sorts of fun stuff regarding the possibilities, but also limits that Christian sees in AI, at least in its current form. I think you're going to get a lot out of this discussion. So here we go. My recent conversation with Christian Hubbs. Christian, welcome to the InFi podcast.
Hey, Bob. Thanks for having me.
Sure thing. So I probably lightly mentioned it in the pre-recorded introduction, but can you give people a brief background as to your expertise in this area of artificial intelligence and so forth, just so they understand why your views are so relevant?
Yeah, no problem. So I have a doctorate from Carnegie Mellon. I did my research focused on deep reinforcement learning, in particular, applied to chemical systems. I had actually been involved in this area since, 2015, 2016. Started getting into hardcore machine learning, deep learning type of work. And we did a podcast for a few years focused on AI back in 2017 up through 2020, and then wound up dropping it. So I've worked in the field for almost a decade now. I have the formal academic credentials and have been a hobbyist as well. So I've been passionate about it for quite some time.
Okay, great. And then also, I had you on an earlier episode when we were talking about various things, including AI. So we thought it'd be great to have you back. Now, in this particular episode, I think we're going to focus primarily on the issues of what's called AGI, artificial general intelligence. And then that leads naturally always into the topic of super artificial intelligence. So I know you said that the recent Nobel Prize has some relevance to this. So I'll stop there and just kind of let you take the show.
Yeah. So this past week, Geoffrey Hinton has won the Nobel Prize in physics. And those who aren't familiar, Hinton has been in this field of AI for a long time. And he's really kicked off this whole deep learning revolution that's brought it back into relevance over the past 10, 15 years or so. And that's just kind of pounding away and hitting breakthroughs in the late 2000s, I guess, 2009, 2010 era, and then into some of the image network and so forth. He won the prize, and he had some comments around some of his students, in particular, Ilya Sutskever, who was with OpenAI before, and kind of casting shade on Sam Altman, who is the current CEO of OpenAI, because he's not taking AI safety as seriously as he thinks he should. He's more focused on profits and so forth. And so this kicked up this whole debate around AI safety, AGI, superintelligence and stuff over the past week within the broader AI community again.
So out of curiosity, so the Nobel laureate, is that person someone who's publicly known about warning about AI safety, or just his student is?
Hinton has been as well. He hasn't been as outspoken as some people like Eliezer Yudkowsky, who people might not be familiar with.
It might be hard to conceive of someone more outspoken than that guy.
Yeah, so he's been kind of on the forefront. Nick Bostrom, Ray Kurzweil, these are some of the guys who have been very concerned as of late. And then, with ChatGPT coming out a couple of years ago and really making waves and becoming most people's first tangible interaction with AI and AI systems, that they're really aware of it and actually going out and using it. A lot of this stuff has kicked off really in the past couple of years. And I feel like it died down a little bit. And then with some of the comments this week, it kicked up again.
Okay. Partly the reason I was asking that is because sometimes there's suspicions that the Nobel Committee, and then also with the Swedish Central Bank, the one that does the economics analog of the, quote, Nobel Prize, that it's done because the people want to shine attention on something. And so that's why I was wondering, like, if this guy was particularly outspoken, is that the Nobel Committee's way of putting their thumb on the scale? But it sounds like maybe that's not necessarily the case here. Well, let me ask you that. We can get onto the juicier stuff for the audience here, but I'm just curious. When you saw that, were you like, that's a well-deserved thing, or possibly thinking that's not really about physics, right? Because it's not like he was out there doing experiments with smashing particles together.
Yeah, a bit of both. I think it's well-deserved. It isn't necessarily about physics, but it does have a lot of applications within physics, when we're bringing machine learning into play. So I had done my master's work in Switzerland, and I knew actually a lot of people in the physics department who were out at CERN. And so they were using some of these systems as well, or other deep learning models and so forth, for particle detection and so forth. And so it has actually a lot of good physics applications. And there are other things that have been derived, like physics-based neural networks and so forth, that use more ODEs, or ordinary differential equations, rather than kind of these linear models that with these nonlinear activation functions and so forth that are currently in vogue. So there are like a lot of physics applications that have come out of it as well. So maybe that's where they're coming from. I don't follow the Nobel too closely, so by and large. So I'm not sure all the criteria that goes into it. But I think as far as an award, this is really a transformational technology. And so I'm happy to see somebody like that get it.
Okay, great. Yeah, you're too busy building stuff at Infineo to be following the Nobel deliberations too much. Okay, so why don't we, jump into then the juicy topic. It fits the pattern of all the people I know who are professionally in the field of artificial intelligence and or just more generally computer programming. They are, including the least worried about computers taking over the world next Thursday. And which is funny because you might have thought it'd be the other way around, that it would be all the people in the field that really are saying, the public doesn't understand how much the strides we're making and things like that. But in general, my anecdotal experience, I get more excited about AI and its potential than the people I know who are computer programmers for a living.
We see how it's made and what's happening in the details. So I'm not too surprised by that. I do think that there is quite a bit within the community that are concerned about superintelligence, for example. That is a very strong subset. And so there's been this big movement around AI safety as of late, where people are looking at different problems and ways to control AI such that it won't take over the world and destroy people, or have more mundane but still negative impacts.
Okay, so do you want to just take a shot at giving the big picture of how you, and by the way, before I forget, folks, we'll link to Christian had earlier on his external podcast done an episode, just a solo one, where he walked through some of his considerations on these topics. So we'll link to that, of course. But do you want to right now, Christian, just give us a taste of how you start analyzing these issues?
Yeah. So I think first, it's always good to define your terms, because this is an area that's kind of fraught with loose definitions, which I think leads to a lot of sloppy thinking when you consider some of the risks or some of the issues that might occur. So first off, a lot of people talk about AGI, or artificial general intelligence. And so typically this is thought to be something that's more or less human level. Some people do conflate it with the superintelligence that, is going to run away and destroy the world. We'll get to in a sec. But I think that these are different topics and different things to keep in mind. I think there are some people who will argue that AGI, the general intelligence, is already here in the form of Claude and ChatGPT and some of these other large language models that are out there. And I'm not too concerned about that. And I think that could be the case. These systems, I use them daily to help with coding, to help with writing proposals, to help with whatever kind of tasks I have, or they're just very helpful tools for me. And so they do seem to be generally intelligent. I can ask them about a lot of different things and get really good, high quality answers that are faster than what I might be able to produce on my own. Or, I can get it and then I can work with it to refine it over time, or take the outputs and then make some corrections and so forth. And so they're really powerful tools. It's like having a very great, assistant with you. Hey, can you draft a memo for this? And it'll come back and it's like, okay, good. Now let me clean this up a little bit. And then, that process takes 5 minutes. Whereas maybe if I was writing it for myself, it'd be 30, 40 minutes if I had to do it all from scratch to the level and quality that I want to.
Can I stop you there, Christian?
Yeah.
Can you just spend a bit more time on that topic just to give people an idea? Because that is something that I've seen when people poo-poo the whole thing, and they'll show examples of, like I was just doing a podcast with this guy, Adam Heyman, and he had a example where if you try to play 20 questions with GPT, I don't know which version it was, it's clear that it's just, I know the whole thing is it's simulating. It's not like it's really thinking. There's like a little guy inside who's typing answers. but it's clear that it's not thinking of some object or a movie or something and then answering your questions. Like it's just giving the form of the response. And so my concern is that if that's all people ever experience is cute little things on Twitter where people do screenshots of, look at this, they couldn't figure out how to get the two animals across the river, like those little, those puzzles that you'll give to a 9-year-old or something. Right. That I'm just saying, when I am working on like an economic issue or something, that this thing, if I spend the time to give it the context, it's as good as a grad student, and it has way better computational abilities in terms of like in its quote head. You know what I mean? Like it's so. Can you just speak to that a little bit? Like, how good of an assistant is it? Like, if you hired a human who had a background in certain things, would the human be better, or is it but this thing, it kind of just knows a bunch of stuff that humans would have to go Google or?
Yeah, it's hard to make that direct comparison to having a human assistant because it's a lot faster
right.
in many cases. So even if the results might not be as good as a top-notch grad student, the fact that it can turn it around in a few seconds rather than having to wait, I think is a huge productivity boost and a big gain for using these systems. And I think you have to use them correctly. I think a lot of people will just play around with it and they'll type something in and get like really bad responses and then kind of throw it away. So I've noticed this with my wife. So I gave her my access to my GPT subscription. So we share it. So I see the list of stuff that she's asking as well. And she started using it initially, and it would just be kind of one sentence question, about like some medical thing with the kids, like, oh, hey, what's going on with this? Do I need to be worried? And she would just use it to kind of get some background before talking to the doctor or something like that. It's like, hey, I know this wasn't a great response here. Like maybe if you ask it like this. I showed her how to prompt it, how to work with it. And then it kind of like opened up her eyes where she realized, oh, this is actually really cool. I can use it for all sorts of things now that I can give it more context. And I'm not just asking, a single basic little question, but, really to help me think as like a partner, thinking through these and to go back and forth, ask questions and get prompts and get responses and so forth. That doesn't mean it's right every time, but that's still a very, very powerful tool to be able to have, especially for someone like me. I had a mentor back at a previous company I had worked at years ago, and he was very well regarded in his field, won lifetime achievement awards and so forth. I used to bounce problem ideas off of him, and I would talk. He commented one time like, hey, I'm happy to be a potted plant in the room because you always just solve it by just talking to me, without me getting responses. And so just having that kind of interaction for me is incredibly powerful. Just being able to be like, hey, look, I've got to explain this. And then just in that process, I can usually solve problems. So using these systems that way and getting that kind of feedback a little bit, I find it to be incredibly helpful.
Yeah, it's kind of like the analogy I've used is sometimes if I have like in my field, it obviously is like an economic issue or like there's something like, I don't know, let's say Paul Krugman wrote something crazy and I know he's wrong and I can sit there and do a standard thing, but it's like, I feel like I'm not quite, like I want to come up with something and get the reader to be like, oh yeah, I totally see now, what an idiot. Or, that's completely fallacious argument that Krugman's using. And I might go for a walk and just play with it in my head for a bit, or I might go on a drive and like I have to talk to myself and walk through. And so, to have GPT-4 or whatever on the other end of that it helps. It's like organizing your thoughts or something, or is it like keeping your thoughts more rigorous or something? It's like doing computations and using Arabic numerals and like, it's easier to add up a bunch of numbers if you have a system in place and you line them up or something. I don't know if that's so. Yes, I totally see that. And again, I would just say to people, if you have just thought these LLMs, large language models, are a fun little curiosity and can't help you in your work, it may just be because you don't know how to use them right.
Yeah, they're great for coding purposes too. And I'd seen people make this sort of mistake where they're like, hey, this is terrible for coding, because they'll just ask like, hey, write me code for using this random API that's out there. That's not very much context. It's not going to work very well with that. But if you can provide it that information up front and say, write a function in Python or C++ or whatever that interacts with this, and then it can actually give you some good responses and good feedback that you can actually work with. If you just start from nothing and just say, hey, what's this? It's probably not going to do a great job unless it's a very general, question like, hey, what's the capital of France? Okay. It'll answer that pretty well. But giving it additional context, like one of my favorite coding uses for it is to have it write tests, because unit tests and functional tests are just a pain to write. But this is something where you could just copy code in, drop it in, hit enter, and say, like, write me the tests using PyTest or whatever framework you want. And it usually does a pretty good job of that, just out, and can save a ton of time and speed up your results. But I realize we're getting off on the...
No, that's fine. Okay, so your point was, arguably, you would say, depending on the definition, it's arguable that they already have achieved artificial general intelligence, in the sense that it's not just like these models can help you write C+ or something. That, no, I mean, the same thing that you're using to help you code, I'm using to help me think through implications of, hey, what does it mean if the data looks like this for labor force participation? Or what are some other hypotheses that could explain this data besides just that, oh yeah, the economy's great. And then it generated some, and some of them they were internally inconsistent, and I pointed it out. I said, yes, I'm sorry. Here, what about this? And it fixed it, the stuff like that. So, but it definitely was like I had someone there in the room brainstorming with me about economic stuff. And so clearly this thing, so, all right, so you got that. I suppose the objection to that would be to say, well, yeah, but when we say artificial general intelligence, we also mean things that are, quote, common sense. And a lot of this, it just doesn't, you can ask real basic questions that it doesn't know the answer to. And I would say it's because it hasn't like grown up in a body in the world. And so there's certain things that we all know from direct experience that isn't written down in a book anywhere because it'd be so obvious.
Right. And I think that gets to one of the potential critiques of superintelligence too, is the lack that it isn't embodied. So it misses a lot of this broader context. So some of the early criticisms that I had seen is that people would ask it basic questions about, can an object of a certain size fit into like a small car? Or how would you do this? Like fit a refrigerator into the back of a VW Bug or something like that. I don't remember the exact example, but it was clear as a human reading that, because you know the sizes of these objects and so forth, that like, yeah, that's not going to fit. But it would hallucinate and generate this clearly ridiculous scenario where, oh yeah, of course you can do it if you open the window and then you just push it. It's like, no, clearly that's not going to that's not going to happen, because it doesn't have any of that experience. It's simply trained on the text that it sees online, that the text that's been pulled down, transcripts and so forth. That's what it's given as far as its training data. So it doesn't have that kind of broader experience. So yeah, it's going to fall down in those areas where it's never had, it's never been able to learn or have those kind of real world experiences. So is that a limitation for calling it AGI? According to some definitions, sure, because it's not embodied. It doesn't have, it can't do these kind of common sense reasoning type of things. Does that mean it's useless? Of course not, because you can still use it for all these great things that we talked about. So reasoning about economics, code, helping with your day-to-day job, whatever that might be, regardless of what its capabilities are for, fitting fridges in small vehicles.
Okay. Out of curiosity, in your framework, does the Turing test come into this at all? Like, is there any place at which you would use some version of that? Like a thing that I had come up with was to say, I think I was narcissistic enough to put my name in something like, I think called the Murphy duration or something like that, or to say, like, what's the length of time that someone would have to interact with the thing to be able to be pretty sure that, wait, I don't think I'm talking to a human here. And that presumably that would just keep getting longer as these things get better. At some point, like, what is it that you'd have to talk to it for three? Oh no, I know what it was. If you embedded it in a robot body that looked human, and then the idea was, well, how long could somebody interact with the thing before they were like, I don't think that's actually human. And suppose you could go 2 years, like, surely we'd call that artificial general intelligence. So like that was kind of the argument I was making, that some of the critics, you just make it by definition, no, it can never be. Like, you could be married to one of these things and go 40 years and maybe you'd be wondering why you weren't ever having kids maybe. But other than that, you just say, no, because actually these things don't have a soul. And so therefore, they don't think. I mean, that's fine. And maybe we can get into the metaphysical stuff later. But my point is just, I think with some of these definitions, like they were setting the thing up to fail. Like there was no way even in principle it could ever pass the hurdles. And to me, that seems kind of like not in the spirit of what these questions are about. Yeah.
And personally, I don't know. The Turing test, I think, is a nice heuristic. And for those who don't know, that's the idea that if by conversing with one of these systems, if it convinces you that it's a human, then it's passed the Turing test. And so I think that these systems have done that. You can have conversations with it. You can always try to trick it and get it to, there are ways to get it to mess up and give you strange responses that you're like, okay, that's clearly not a human. But as a decent heuristic, I think it's fine. I don't put a whole lot of weight into it because the way I see it is that these are kind of just differences of degree. There's no clear black and white line where it's like, yep, we've crossed over. And this is because one of the issues in this space is that intelligence itself is just really poorly defined, let alone, general intelligence and so forth. And so that becomes, I don't know, I'm not willing to die on any of those hills.
Okay. All right. So if I understand your position, you're saying in a sense, though, people seem to believe that, once it hit AGI, then we're dead, because if it got to the point where it was well-rounded, well, then it could just go off on its own and then just keep improving itself. I think that's the fear that, like, if there's some engine that's really good at playing chess, it's fine to just let that thing sit by itself and just run, more and more teraflops and blah, blah, blah. And what if it just becomes so amazingly good at chess that we can't even conceive of how good at it? And it's like, well, okay, so what though? Who cares? Like, that, the worst is going to happen is this thing's just going to get so unbelievably good at chess, we can't even conceive of it. But it's not going to also then knock out the president and install a puppet dictator or something. You know what I mean? And so, but the concern is, if the thing just gets good enough that could passably be a human in all the other walks of life, and it still has the ability at night to sit there and work on itself and make itself 1% better each night, then we're dead. That's kind of the fear.
Yeah, and I think this is laid out well by guys like Ray Kurzweil and Nick Bostrom. So Bostrom is famous for his paperclip maximizing thought experiment, where he talks about the idea of researchers will be working with what he calls a seed AI. So just a really basic AI system that's then let loose, and it's able to start training and improving itself. And it's given a simple mundane task like trying to generate as many paperclips as possible and figuring out, okay, this is your goal, maximize paperclips. And then you run an experiment. This is common in academia and computer science, where people will say, okay, like, let's just play with a little toy problem like this, give it something simple so we can just measure and examine what's happening with the system. Is it achieving this? Is it not? And we can go back and we can tweak it. And it's easy to control the variables with that. So somebody gives this CDI this mundane goal of creating paperclips. And then because it's a CD, like a proper AI that's going to actually improve itself over time, then what it does is it starts to learn more about the world and figure out more long-range planning, try to determine what could inhibit it from creating this goal. And so it will realize, hey, these humans could be a threat to me. I might need to isolate myself or copy myself onto other systems and distribute myself so that I can't be unplugged or taken out. Once it does that, it'll start to learn about, okay, now how do we try to get these paperclips to be made? And then once it gets good enough, it'll start to improve itself and be better and better until it's starting to just maximize as many paperclips, and it basically turns the entire planet to a big paperclip and and so forth. That's the thought experiment that he goes through. And a lot of people, I don't think, take it seriously because it is pretty ridiculous, like talking about maximizing paperclips. But that's also part of the point that Bostrom is trying to make with this, is that something that might seem very mundane and very simple could lead to these runaway scenarios if his assumptions about AI are true.
Okay, yeah, I liked it because at first I almost intervened and thought you were going off on a tangent. I mean, I knew that was a cool thought experiment, and plenty of people have talked about that. So it wasn't that I didn't want to talk about that, but I thought at first, oh no, Christian, that's different from what I'm talking about. We're talking about like the Terminator. But I guess that's what he's getting at, is to say the threat of super AI is not simply a Skynet type thing where it seems like it's this malevolent thing that is like an alien race that happens to be embodied in computers and emerged from us. And, oh, geez, we should have done better with our programming. That, no, it could be, like you say, just a system that's just, quote, mindlessly cranking out paper clips. And if we just if we want it to be able to learn and we put it into a controlled environment in an office setting and say, oh, look, it's going around and it's taking some staples and it's like bending them. That's interesting. That's clever. Oh yeah, it's turning the staples into more paper clips. Very good. Okay, but right there, you've kind of opened Pandora's box, because if you're allowing it to do something novel like that and the system's capable of learning how to do that, well then in principle, yeah, couldn't it also learn that, oh, the way to keep making more paper clips is, first of all, to take out all these pesky carbon-based life forms that are trying to stop me for some reason. And
yeah, that's a risk to my paperclip maximizing objective. And so we need to do something about it. So yeah, that's what a lot of people are concerned with, is that it could be something very mundane, it's something very simple that just gets this runaway exponential increase in power and intelligence in order that winds up destroying the world and bringing it down. So some people talk about, the alignment problem, ensuring that these are actually going to be taken care of, or like as it gets better, that it's aligned with human objectives and human flourishing. And people will also talk about, if something's, make the analogy of, say, humans to animals. If something's just this incredibly intelligent, it might not even mean any harm to us, but it could still wipe us out. Just like we put a Walmart down the road and all those rabbits and birds and everything that was living in that open field are now dead or displaced because they have no idea why a Walmart went in. Something well beyond their ken. And so we just crush them because it suits our interest, even if we like the birds and the rabbits and everything else that was there. People are concerned that that same sort of thing could happen to us in light of these super intelligent beings.
Okay, so I forget the guy's name. It was on the InFi podcast though, but one person gave me a little, I thought, good clarification or reality check on that, is I had gone down the path of saying how we program the thing and then it takes us literally. And so it's not, because I think the conventional understanding is, oh, we could give it program, but what if it learns to ignore its programming and it has its own desire? And I don't think that's quite as really. I think the more interesting and plausible thing is where it does do what we told it to do, but we didn't realize the implications. And so I think that's actually in the Terminator movies. I think that's what happens with Skynet, is it really is trying to follow its programming and just realizes these humans are irrational, unpredictable, and the way I can make sure like the United States doesn't get conquered by the Soviets or whatever it is by just killing everybody. And then now, because the Americans could be traitors, they might sympathize with the I'm making that part up, but I think that was the idea that they were saying. It was Skynet wasn't. It's not that it ignored its programming; it's that there was a quirk that the way they actually phrased it. And so the example I gave to the guy is I said, like you tell the supercomputer, make me a sandwich. Oh no! And it takes you and rips you apart and puts bread around you and so forth. And he chuckled, but then he said, "But no, of course that wouldn't happen, because if the thing by hypothesis is sophisticated enough that it is discovering new laws of physics and things, and is way beyond us, and it could crank out literature that we could never dream of doing, it's going to understand the difference between make me a sandwich and turn me physically into a sandwich, prepare me a sandwich versus turn me into one. Like that's a very basic thing. So there's a mismatch. His point was to say that it's this capable and powerful and intelligent and blah, blah, blah. And yet it doesn't understand that, when the humans that made me and gave me all these other commands about how I should try to take care of them and everything, then also ask me to make me a sandwich. Anyway, you get the point. So I'll stop there. So I guess the idea is, does it actually make sense that if by hypothesis, this paperclip making system became so powerful that we couldn't stop it with all of our military and stuff, like if it were that smart or intelligent, maybe is the right word, wouldn't it also know that turning the Earth into a paperclip is not what it needs to do?
Yeah, and that's where some of the basic assumptions that underlie these arguments need to be explicated, I think, because I think that there are a lot of hidden assumptions that people who promote these types of thought experiments, like Bostrom and Kurzweil and Yudkowsky and others, that they don't stop and think about, and they just kind of go forward with it. Well, like, yeah, of course it's going to be super intelligent, and of course this is going to happen. And they kind of they paint this narrative that you got to be like, hang on, back up, like before we get to there. Like there are like 10 more steps of where things could go very, very differently, or you're making an assumption here that I don't think is warranted. So, which is why I'm not too concerned about a lot of these super intelligent systems. I think AI could be dangerous in the wrong hands when it's being used for malevolent purposes and so forth. But these runaway super intelligent systems, I don't think are anything that we need to lose sleep over.
Or at least I would say not for the reason that not for the reasons of like the paperclip example, right? So I mean, because I do want to now get into it, but I just want to underscore again for the people who haven't really interacted and quote had conversations with one of these LLMs, especially the more advanced models. I can see how you might just think, well, no, but it's not thinking. What do you mean, Bob, when you said that wouldn't it know not to obey its paperclip programming, or wouldn't it know that to make me a sandwich? Like, it doesn't know anything. It's just a bunch of zeros and one. And okay, but I'm just like one I had a year ago at this point. It was an InFi episode where I had a conversation with GPT-4, and I was going back and forth with it. And I said something like, oh, yes, it's like Aristotle, how just, using questioning to pull forth what the person already knew. And then in the answer, it said, yes, the Socratic method. And and then I said, oh, yeah, you're right. I got mixed up. I said Aristotle. I meant Socrates. By the way, did you not mention that because you didn't want to embarrass me? And it said, oh, no, it had nothing to do with embarrassment, but I understood your meaning. And I was, and, yes, I realized there's not some mind on the other end that's worried about my feelings, and but it sure gave the appearance that it did. And so I'm saying, likewise, I don't think the thing that has the ability to make a force field to knock away our incoming ICBMs is also not going to know that make me a sandwich isn't me asking it to kill me.
Right.
Or get the appearance of knowing. But I'm going to stop putting "no" in quotation marks. But anyway, that's a...
Yeah. And I get that too. It becomes a question of, okay, does it know? Does it understand? I'm skeptical on that. If it does in the same way, I don't think so, because I think that we think very differently than how these systems actually generate their text. But we can get into that a little bit later, because they basically just predict whatever the next tokens are going to be.
Right.
And I think we tend to reason a little bit more inversely, where we think about where we want to go and try to think backwards about how we get there. And we can go back and forth between that kind of prediction mode or other things. But I think the human mind is much more flexible in the way that it actually processes this information.
Okay, so what I did want to definitely do, and maybe this ties into what you just said. You tell me. So it sounds like you and I are in agreement that yes, just the blind, like, oops, we didn't think through the consequences of our actions, and we programmed the thing and it took off, and it just kept getting better and better, and it got to the point where we couldn't stop it, and then it turned on us again, not because it was malevolent or, quote, had a mind of its own, but no, it was doing what we told it to, and it just got out of hand and we couldn't stop it. That we think that's probably not right, that a machine that with those kinds of abilities would also understand us telling it, okay, we want you to stop. And so the question then becomes, all right, why then, Christian, aren't you afraid of the artificial intelligence becoming, surpassing its programming, as it were, and just getting a mind of its own, and then deciding, we're not taking orders from you guys?
Yeah. So when you look at the way these stories are typically framed, there are a number of, like I said, hidden assumptions that I think need to be brought out. So one is that these things seem to have an exponential improvement in intelligence over time. You can see this in Bostrom's book, Superintelligence, where he has a plot that's basically the right half of a parabola. Like, oh, well, this is where intelligence is going, up and to the right and exponentially increasing. And, you got, I think if I'm recalling the image correctly, you've got basically people on the axis too, and like, well, it gets way past us and it just increases forever. I don't think that that's plausible for a number of reasons. There are a lot of issues with things have limits. As an economist, you know about the law of diminishing returns, right? Mm-hmm. And this is something that turns up in AI as well as everything else that we're working on. You can go and Google some of the images or some plots around, say, GPT, Sonnet, some of these other models that are coming out, and look at how they've progressed over time, these large language models. And what you'll notice is that they're typically on a log scale. You might find some that show their performance against benchmarks and their parameters. And what you'll see when you plot these against each other is that the parameters tend to increase logarithmically. So there's an exponential increase, maybe even a super exponential, where it actually is bending upwards on the log scale. It's compounding much, much more quickly. But what you see is that the benchmark performance is sublinear oftentimes. In other words, it's basically plateauing. And it's so you're getting more and more resources going into these systems, more and more parameters, more and more compute, more and more data. And what's happening is that they're getting, now they're up to 87%. Now that next generation puts it to 88% accuracy on these benchmarks, 89 and so forth, instead of this big exponential increase upwards, which is what I think we would expect, especially without any sort of fundamental improvements in how we're developing these deep learning systems, which are these large compute and data hungry models. Had taken massive amounts of data and have massive amounts of computation requirement in order to be able to generate these predict the next token, basically. Something very simple that winds up being very powerful in use, but they aren't increasing in this exponential fashion that a lot of these runaway superintelligence hypotheses expect it to.
Okay, so just to translate that, you're saying so far in practice, even though, yes, we have seen remarkable improvements like GPT-4 and then the later versions is way better than GPT-2.
Mm-hmm.
But you're saying for each increment, they're dumping way more resources into the thing to get that extra improvement.
Yep. Yeah, GPT-2 came out in, I think, 2019, 2020. I remember downloading it and being able to run it on my machine, play with it and train it. And I had some plans to set it up to write like these blog articles for me and so forth. And it was fun to play with, but it didn't change anything. It didn't change anything about the way it worked or it was cool and it was interesting, but it would quickly devolve into nonsense and gibberish without much prompting. Context window was tiny. It feels like playing on a Super Nintendo versus today's systems, just the gap and the change. But it's also multiple orders of magnitude smaller and less capable. Like I was able to run it on a standard laptop and GPU. I didn't have to have any special servers, didn't have to have anything special to be able to get this up and running. And I was able to, download it and play with it. It was simple. Today, there's no way, these large language models to run GPT-4. I mean, it's estimated to be in the trillions of parameters. It's huge. It takes so much more compute and so much more data in order to get to that level that we're seeing. So you're really putting more and more in and getting less and less out every time.
Okay. And so you're saying just if you naively extrapolated the trends, it's like to get, I'm making these numbers up, but to get somebody who's 5 times as intelligent as the smartest human right now would take $60 quadrillion. I'm just making this. Yeah. So that's the sense in which why you're saying you don't think that, oh no, yeah, we just got to wait and look at the improvements of the last few years and we just go forward. That means by 2050, it's game over. That you're saying no, because also looking over the past few years, they've been just dumping way more into these things. And there is going to be a point at which you can't devote 80% of global GDP to training the next batch of LLMs.
Right, so that it hits 93% on the latest benchmark or something like that. You get the law of diminishing marginal returns. It just comes into bite, and this is not taken into account with a lot of these systems. They need more electricity, they need more GPUs, and so forth. But I made the point.
Right. Can you though just give us your ballpark just to make sure? Because you're saying like a 93% of the benchmark. I mean, is there any reason? What's 100% of the benchmark? Is that human level or is that perfection?
That's perfection. It depends on the benchmark that you're looking at. So some of these benchmarks are better than others, more robust. So a common one is the MMLU, which I think is the multimodal language understanding. So I think it stands for, which is pretty common. There are some issues with it. There are some errors within the benchmark itself. And there's also an issue with in machine learning when you start to train against a benchmark over and over again, you're basically like fitting your model to the test. And so you wind up inadvertently getting that test data kind of into it. So it can lose its meaning over time, but this still winds up being one of the common standards. And there are others that are out there that people are putting together and have played with and are augmenting as you go. So whatever those benchmarks might be, 100% would typically be perfect. I don't know what human level would be on some of these. And there are some other constraints that you can typically put in, like how many, like if you have like a 5-shot versus a 0-shot or whatever, different constraints on how many opportunities it gets, the context and so forth.
Okay. So last one on this, and then we can move on to a different subject. So again, I think everybody understands the point about diminishing returns, but by itself, that doesn't calibrate it. Like, couldn't it still be that, oh yeah, for another $1 trillion expenditure, where they can make it a large language model that for all intents and purposes is better at physics than Stephen Hawking and better at computer programming than Christian Hubbs and better at economics than me. And not that I'm the Stephen Hawking of economics, just want to say. So, right, you get what I'm saying? And yeah, that wouldn't disprove the law of diminishing returns, but also it could show that for all practical purposes, the company that first spends that $1 trillion and develops this thing could basically take over the world. Because the deal too is it's not just one. Like my understanding is that it's the training that is so resource intensive. And then once you have all the dials set on the parameters and everything, then you can make multiple copies that don't take as much to run.
Right. It's much more efficient. It can still be expensive to run it. There are some breakthroughs. I actually have a good friend who's working in optical computing to make computers basically that run on light that are much cheaper, faster, more efficient. Yeah. So there are other breakthroughs that are coming through to be able to make these cheaper to train and to run and coming forward. So even,
but just to make the point that suppose it were the case that, if you spent $1 trillion training this next generation, this thing would be really amazing. My point is, it wouldn't, to get two of them running simultaneously, you wouldn't have to spend another $1 trillion.
Right. It would be orders of magnitude less than that to get something else up and running, assuming that you can actually properly run it across the data centers and so forth. Maybe you need a few data centers to run it.
Sure.
But that's...
Again, just to restate the question. So yes, that's all, but that story is consistent with diminishing returns. And so just by saying diminishing returns, how do we know that, so we don't need to worry about this?
Yeah. And so this is where, some of the other big gloss over some of the other details with it. So when it comes to the idea of it being, I don't want to get too technical, but with this self-improvement and this recursion that they wind up positing for these AI systems, I'm highly dubious about that, especially given, how we currently train them. We currently train them with a very dumb algorithm called stochastic gradient descent, which basically just applies the chain rule and it tries to move to whatever is going to minimize the error prediction that it has over the training data. So think of, you're basically walking up a hill, does a little calculus to figure out what the gradient looks like on the hill, and it will just go in whatever the steepest direction is based on the information that it gets. It keeps on moving through those situations. So even if we have a more sophisticated way for it to be able to update, it runs into a problem with this kind of self-referential capability where it can improve itself. There's an issue in computer science called the Turing halting problem, which is basically the idea that you can't determine whether or not a program... So actually, let me back up. There is no general program to determine whether or not a program is actually going to stop running. That sounds really mundane, but it's actually a very deep problem within computer science, because any kind of program that you might run could fail to halt. And so there are certain limitations, certain algorithmic complexity issues around trying to determine whether or not something is actually going to, any kind of code change is actually going to cause an improvement, or it could have it just run away or run into some other issues. So if the model is trying to improve itself, it doesn't actually have any way of knowing for sure unless it can solve the Turing halting problem, which introduces paradoxes, which is why it's a theorem that, hey, this is an unsolvable problem, where it's actually not going to be able to improve itself with any kind of guarantee. So it could very quickly derail and decohere. And we're actually seeing something related to this a bit with these models that are training on LLM output. So this is also an issue with LLMs going forward and putting out new ones, is that a lot of the internet and a lot of the test data is being polluted by LLM created data. Mm-hmm. And what researchers found is that when you try to train a system on the output of GPT-4 or Claude or whatever the latest state-of-the-art model is, you're like, hey, this is great. I can just have it produce data and then I can use this for my training data to bootstrap my own system. It actually performs really, really poorly. And it very quickly goes into this, what's called model collapse or model decoherence, where they suddenly produce gibberish and garbage. And there are some fundamental reasons for that. I like the hypothesis that ties back to information theory, that because these systems are stochastic in nature, meaning that they have randomness, they produce different outputs randomly, then this introduces entropy or disorder into the system. So it winds up losing meaning. And so the more of this that gets actually introduced, you're basically increasing the amount of noise that goes into train your next model versus the signal of actually like meaningful human generated content that you're trying to predict and you're trying to get. And so as that becomes greater and greater over time, these models become more and more, they start to collapse. There are other distributional shift issues and other theories about why this occurs as well, but it's a well-known phenomenon at this point.
Okay, great. Let me try to give a simplistic fable to illustrate what I think your more general point is, and you tell me if this is a good distillation of it or if I'm missing the point. So yeah, let's say these big companies, they're spending a bunch of money and they go out and, this thing, it scoured the web and downloaded this many trillions of bytes of data and trained on that. Okay. And then this one, we spent even more money and it downloaded a quadrillion bytes of data. Okay. And trained that. And then when it gets to the point that it's trained on the entire internet, as of the moment when it downloaded it. And so how can it get any better? And then we can say, I know. Let's tell the LLM at this point, it's like GPT-17. Let's tell it to simulate an Earth and have some people, and then it simulates inside its own model a World Wide Web that has all kinds of new information on the internet, and then it trains on that too. And then, so see, now we've just opened up a whole new world. We'll just let that thing run for 3 weeks and it'll have 16 quadrillion different planet Earths inside its simulation and train and all that. And so and then you realize, well, there's kind of a problem there that if it makes sense when the system is crude and it's like learning from, loosely speaking, the human intelligence that's been already scattered around on the World Wide Web. But then once it's absorbed all that, how can it generate more stuff that it then learns from itself? Like that, there's a weird, is that kind of what you're getting at?
Yeah, that's an issue where it gets this feedback. And so it starts to train on itself. It can start to narrow its distribution of what it's actually going to choose. And so this becomes a vicious cycle that it will start to occur. Now then, to like simulate, I think the issue that you pointed out is also very relevant, but slightly different, where, if you're trying to simulate, say, worlds, for example, you're going to have to lose a lot of fidelity. There's the old saying, the map is not the terrain, right? There's a reason why we have maps, is because they are abstractions of what the actual physical terrain looks like. Now, if you want to actually have something that has all the richness of the world, then you basically have to have the world. There's kind of like no way around that, to do that in simulation. And this goes into even like quantum computers. Like the original idea that Feynman had for quantum computers is to do quantum simulations. Like, hey, can we just do experiments in the quantum world using quantum computers to see how these things interact? That should be the simplest thing that we can do, is actually just quantum chemistry here. Same kind of idea. You don't want to confuse the map for the terrain. So if you start to simulate try to simulate the richness of the world, you're going to be losing out on a lot of the nuance and a lot of the details. And then those systems that are trained on that, they wind up falling down when they get thrown out into the real world. So I think it's a slightly different issue, but related.
Okay. All right. Fair enough. I guess one thing though that I still, like, this all makes sense to me, but couldn't somebody come back and say, you guys, you're proving too much? That couldn't you use the same kind of reasoning to say, an engine that knows the rules of tic-tac-toe, there's no benefit to letting it sit there and think about stuff for 3 weeks before you go to play it, because, it just, entropy has to go up over time. And no, that's not right. That within 3 weeks, your laptop has the ability to just go through every possible game and then work backwards and then know the optimal play in any situation. And it's never going to lose. It's going to play perfect tic-tac-toe because you allowed it to think about it ahead of time. And so could there be something analogous to that you let, GPT-17, you just let it sit and think for a year, and then you come back and check in on it, and it's just going to have way more power mentally, however you wanted to define it, than it did the prior year.
So tic-tac-toe is a very well-defined problem. And I think the difference is that we know very clearly what optimal play looks like in tic-tac-toe, or at least what the goal is in tic-tac-toe. When it comes to intelligence, we don't know what the goal is. Like,
okay. I'm sorry to cut you off, but basically, good. I'm glad we're getting to this, because that's kind of the issue. So I'm saying, couldn't the person who's saying, you guys, I'm telling you, we're going to be blown away by what these systems can do in 10 years. Couldn't you say, the goal is, and give very well-defined like math problems to solve, and it make it so it's smart enough to know what a valid proof looks like. And then here, just throw stuff at the wall and see if you happen to find it. Could do that, or I don't know, with physics or something, like, figure out how to do cold fusion, and we can be very precise about what we mean by achieving cold fusion. Go. And the system can tell whether it did it or not, and let it try for a year and come back to us, and we'll see if you did it or not. So couldn't you just do stuff like that and give it pretty well-defined metrics of what it means to succeed?
Yeah, but that's different than the self-improvement issue.
Okay, well, I mean, I thought you were, I think we agree with the tic-tac-toe that, there's a sense in which you let the thing sit for a bit. It doesn't need to go consult outsiders. It can figure it out. And then I thought you were saying, but that's not the stepping stone to super intelligence across the board, because there's the well-defined task. I'm saying, couldn't you give it 15?
Yeah, and I'm saying that's still not the stepping stone to super intelligence, because that's not necessarily a self-improvement type of issue where you get into that kind of recursion issue that I had mentioned with the halting problem or with the training data. There's also an issue that you can bring that's a little bit more philosophical, that comes from intentionality and consciousness. And so I think that consciousness is actually necessary for a lot of this to actually occur, to actually have self-improvement. I think You need to get through consciousness because you have to be able to think about yourself. Now, there's a...
Can I stop you there?
Yeah,
so why don't we, I'll give you a chance to spell that out, and then we should end on that note just because of the clock here. But okay, so at first I thought you were being a politician. Now I get what the distinction you were making there. So you're saying it's one thing to say, yeah, let GPT-17 sit in a room or a big warehouse or something full of processors and just think about various problems for a year and then come back and maybe we'll have made progress in a lot of them. But when people talk about runaway super AI, what they mean is the thing that it's thinking about for a year is how do I make myself into a better LLM or, more generalized description of artificial intelligence engine. That's the thing that, because even if it's just, 1% per week, well, there you go. It's going to run away. And so is that what you're saying? That no, it would still be GPT-17. It's just like, look at the achievements it's done, but it doesn't mean that all those different discoveries about, it cranked out a bunch of math theorems and it discovered some new laws of physics and blah, blah, blah. It wrote the hilarious haiku that anyone's ever come up with. That doesn't mean now it's going to be even better. And the next year it's going to discover even more stuff because it's improved itself. That was the distinction you were making?
Right. And I'm glad I'm not a politician. So that's but yeah, exactly. Because it's a different problem. If you're trying to solve cold fusion or whatever, that's a different issue than trying to improve yourself. And the concern is that it will get into these self-improvement loops while it's trying to solve these other issues, such that it will become this super intelligence runaway, develop its own goals and so forth.
Okay. And so then for people to kind of get the intuition of, well, why wouldn't it be able to, couldn't you just give it the instructions to say, this is what we mean by saying you're improving yourself? And there it gets a little bit vague and it kind of takes a human to be able to say, no, that's not right. Like in the training of these things and to do the next batch of the LLMs, humans are involved to be able to guide it and coach it and whatever to give feedback. And if you didn't have those humans occasionally coming in and saying, no, that doesn't seem like a good answer to that prompt, then it has nowhere to go.
Yeah, it needs that kind of benchmark to be able to measure its loss function again. So whether you have the MMLU, which we mentioned earlier, that kind of standard language learning understanding benchmark, it's very difficult for it to say hey, now improve yourself, examine your code and figure out how to actually make this better and going forward. There are people who are trying to work on some of these issues, but I think that there's a fundamental issue with that requires consciousness, and this is called intentionality. And so I think that in order to do this and to have that sort of self-reflexive nature is that you need to be intentional. This is also known as aboutness, to be able to think about something. So for one thing to be about another. And these are purely physical systems, these computers, right? And so there's nothing that one silicon chip is really about another. This is a level of meaning and a level of abstraction that I think requires consciousness. There was a quote, I think it was C.S. Lewis, who said something along the lines of, an astronomer might be looking at the moon and thinking a lot about the moon as he looks at it. But it's nonsensical to consider that his brain is about the moon as a piece of matter. There's nothing connecting there because from two physical systems, there is no intentionality. That's something that consciousness actually requires for something to be able to improve itself, to be able to think about itself, and to be able to actually have those types of goals and achieve them. Okay,
so is it fair to say then that, there's a lot more that is going on here, but
let's just open up the hard problem of consciousness.
Right. It is, and we, like I said, we do have to stop here, but let me just say this and then let you respond and we'll wrap it up. That you do think that there is something qualitatively different about humans with their consciousness. And I know you're Christian and presumably that factors into this as well. And that's partly why you don't think that these computer systems are ever going to pose the kind of threat, the specifically narrowly defined threats that some of these people worried about super AI are bringing up.
Yeah, that's part of it for sure, is that I think that there's a fundamental difference between what machines are able to do versus what conscious beings are able to do. And I've never been sympathetic to those who think that consciousness just emerges when something gets to a level of complexity. It always felt very hand wavy to me.
Right.
Oh, well, hey, it's consciousness. Now, that doesn't mean I have a great explanation for it either. It's something that we don't fully understand. But it's one of those things where it's well, that's not an explanation either.
Right.
And you can get to
real
that.
Quickly. Let me. Have you ever heard this one? Unfortunately, I forgot who I heard say it, and that guy I think was just quoting somebody else. But It's a real quick argument that goes like this to say as to why a purely materialist explanation of consciousness doesn't really work is that if you do have that view and you're a materialist and you think really when it comes down to it, it's just the matter in motion and the laws of physics, whether there's quantum uncertainty or not, but still that doesn't change the basic story. And so if in that view, you think that there was the Big Bang and then the gases coalesced and the sun was formed in the earth and then eventually some lightning struck or whatever, and you had the first amino acids doing blah, 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 and then you had life emerge finally. And throughout all of that, if you just looked at it with an electron microscope at everything, the emergence and evolution of Homo sapiens would happen and it would, quote, make sense just within the rules of physics. And then, okay, so then on top of that, there's no reason that those things should have consciousness. That doesn't add anything to the story. Because in your own story, this intangible consciousness is not changing the motion of any of those atoms. Like, no, they're just, quote, blindly obeying the laws of physics. And again, even if you bring in quantum uncertainty, that doesn't mean that, and that's really 2/3 of the time it does this, but that's when the guy chooses to do that. Like, no, that's not random, if that's what you're saying. So that to me seemed like a pretty interesting thing, like to show the standard Daniel Dennett type of explanation that, it emerged through evolution and then it was just a user illusion. And that makes no sense whatsoever. Anyway, I'll stop there.
Yeah. And just to add one thing, Alvin Plantinga had argued about this quite a bit. And I find it very convincing that on a purely materialistic view, which is where I think a lot of these superintelligence arguments come from, is from this materialist view where it's like, well, humans are intelligent. So of course all this stuff can work out and humans are purely material. So I think that's where a lot of this, the core assumption, if you can cut out materialism, then I think you cut out a lot of these arguments as well. But Plantinga had made a number of arguments against the coexistence of materialism and reason itself. So that you basically can't, if you are purely material, if there was no kind of material independent mind or so forth. The basic idea is that if it's simply a matter of atoms and so forth and motion in your brain, there isn't actually any reason for you to actually believe that you've reasoned about something or come to some sort of conclusion. There's no place within the physical universe for reason to actually fit into that area. And then you do see this, I think, oftentimes with AI systems where they're not actually reasoning about stuff. It's just, they're basically just going based on the data that they have. But there's not that deeper level of reason and logic. And I think it comes down to, it doesn't fit into a purely materialistic system.
Okay. Well, that is a very deep point on which to end. Thank you, folks. My guest this episode has been Christian Hubbs, the chief AI scientist here at Infineo and all-around deep thinker. Oh, yes. Tell us what your promotion is.
Yeah, CTO now. So
Yes. But I think chief AI scientist sounds cooler. But yes, you're right.
It does. I mean, yeah, there are lots of CTOs out there. So
Okay, well, thank you, Christian. And thank you, everyone, for tuning in. We'll see you next time.
Thanks.